Hello everyone, this is Yopendra Kumar, Assistant Professor, Civil Engineering Department. The subject is Structural Analysis and the topic is Analysis of a Continuous Beam with Fixed Supports using Three-Moment Equation. Hello everyone, in the previous lecture I had given you the procedure of the continuous beams and had explained you with an example of a simple supports. So in this class I am going to give you another example with fixed supports. So the question is this one. A continuous beam ABC is fixed at A and simply supported B and C. The span AB carries a uniform distributed load of 10 kN per meters. The span BC is 4 meters and carries a UDL of 30 kN meters. Draw SFD and BMD using Clapeyron's three-moment theorem. So, this is a continuous beam of spans AB and BC, where A is a fixed support and B and C is a simple supports. And he mentioned that AB is of span 6 meters and carries a UDL of 10 kN per meter. And BC is of span 4 meters and carries a UDL of 30 kN meters. So, the procedure of Clapeyron's theorem is same. There is no variation of steps from previous problem to this problem. That is from simply supported some supports to this fixed support of continuous beams. But there is only one difference, that is we have to assume another span from this fixed support to the left side, that is A0, which is of length 0 and area 0, everything is 0, but we have to consider it. So now we have to draw the free bending moment diagrams same as previous problem, and step 2 is also same. Step 3, coming to step 3, we will apply three moment equation twice, that is for the beam A0 A B. So we will get an equation in relation with A and B, and coming to next one, we will again apply this three moment equation to A B C. So we will get another equation in terms of A, B and C, where C is 0, MC is 0. We will get equation in MA and MB. So by solving both these equations, we will get the values of MA and MB, and remaining problem is of same of previous method. So now here this is our problem, and step 1 is to draw the free bending moment diagrams. So after assuming the, this section, the UDL for span AB, it is acting with UDL 10 kN per meter over the span of 6 meters. So the bending moment will be WL square by 8. So 10 into L is 6 square by 8 gives me 48 kN meters. Since it is UDL, it will be in parabolic shape. And coming to BC, again it is UDL of 30 kN meters. So 30 into L is 4. So 30 into L square by 8, 4 square by 8, it gives me 60 kN meters. Again it is of UDL, so it will be parabolic shape. Coming to this span A0, since there is no load and this is an imaginary span, this will be 0 and there will be no bending moment diagram for this section. It is a plain line. Next, step 2 is to calculate area and centroid of bending moment diagram between 2 points. So coming to first span A0, area is 0, XL is 0 and XR is 0, everything 0. Coming to since L is 0 here, L is 0, everything will be 0. Coming to second span AB, area for parabola is 2/3 of base into height. 2/3 of base is 6 meters and height is 45. By calculating this value, we will get it as 180. A1 as 180, and XL and XR are for parabola, it is L by 2, where L is 6, so 6 by 2 gives me 3. Now coming to the third span BC, area is 2/3 of base into height. Here base is 4 and height is 60. So by substituting to these values here, 2/3 of 4 into 60 gives me 160. Therefore A2 is 160, and XL and XR is L by 2, where L is 4. So XL is equal to XR is equal to 2. After completing the second step, we have to substitute the values in three moment equation. So now I am applying three moment equation to the span A0, A and B. So this is our three moment equation. MA into L1 plus 2MB into L1 plus L2 plus MC into L2 is equal to minus 6A1 x1 bar by L1 minus 6A2 x2 bar by L2 plus 6EI delta A by L1 plus delta C by L2. I am again repeating, this delta A and delta C are for sinking of supports. There is no sinking of supports in the given problem, so we can neglect this value. I will give you another lecture with the sinking of supports, then we will use this. And I will also give another lecture in which there is a variation of flexural rigidity. That is, EI values will vary from span to span. Then we have to consider EI values in the denominator here. Now coming to this problem here, since we are applying for the span A0, A and B, here MA will be MA0, MB will be MA, and MC will be MB here. And this is L0 and this is L1. So by substituting these values here, our three moment equation for span A0 AB will be MA0 L0 plus 2 MA L0 plus L1 plus MB L1 is equal to minus 6 A0 by L0 into X0 bar minus 6 A1 X1 bar by L1 plus 6 EI delta A0 by L0 plus delta B by L1. And these values are 0. And we had already calculated these values. A0 is 0, A1 is 180 and A2 is 160, L0 0, L1 6 and L2 4. XL and XR of span A0 A is 0. For span AB it is 3 and for span BC it is 2. Now by substituting these values, here this value will become 0. 2 MA into 0 plus 6 plus MB into L1 is 6. And A0 is 0, so this value becomes 0 and this value also becomes 0 since delta A0 and delta B is 0. Coming to this value, A1 is 180 and X1 bar will be for this span, it will be here XR, it is 3 by 6, L1 is 6. So by solving this, we will get an equation as 12 MA plus 6 MB is equal to minus 440. So mark it as 1. Coming to second span, I am considering the span ABC and I am applying three moment equation. So now our three moment equation is MA into L1 plus 2MB L1 plus L2 plus MC L2 is equal to minus 6 A1 X1 bar by L1 minus 6 A2 X2 bar by L2 plus 6 EI delta A1 delta A by L1 plus delta C by L2. Now by after substituting these values, that is L1 is equal to 6, L2 is equal to 4, here A1 is 180 and A2 is equal to 160. I will get an equation by solving this one, that as 6 MA plus 20 MB is equal to minus 1020. Now we got two equations in terms of MA and MB. So now by solving the equations 1 and 2, we will get the values of MB as minus 44.12 kilonewton meters and MA as minus 22.94 kilonewton meters. So finally, by applying three moment equations to two spans, by assuming an extra span A0A and applying one three moment equation to A0AB and second moment equation to A, B and C, we will get these values: MA as minus 22.94 kilonewton meters, MB as minus 44.12 kilonewtons meters and MC as 0 kilonewton meters. Here MC is always 0. We have to consider MC as 0 since it is simply supported end. So this will be 0. So after calculating the moment values, the next step is to find out the support reactions. So for finding the support reactions, we have to divide the beam into different spans. So now already we had calculated the values of MA, MB and MC. Now by substituting these values here, I had divided the beam into spans AB and BC. Now by applying equilibrium equations to each span individually, we can calculate the values of RA, RB and here RB, RC. So for this first span, applying summation of vertical forces to 0, RA plus RB is equal to 10 into 6. So RA plus RB is equal to 60. Now I am considering moment at this point is 0, MB is equal to 0. So the forces to the left side of the section of these RB values are RA and this 10, and the moments are 22.94 and this value 44.12. Now here this RA value will be positive since it is acting left side clockwise. So RA into 6 will be positive. Coming to this 10 into 6 into 3 will be my moment acting here, and since it is acting left side anti-clockwise, it will be negative. And coming to this 44.12, it will be positive, and coming to this 22.94, it is left side anti-clockwise moment, so it will be negative, which is equal to 0. So by solving this value, we will get RA as 26.47 kilonewton meters, and by substituting this RA value in this equation, that is RB is equal to 60 minus 26.47, we will get RB value as 33.53 kilonewtons. And coming to this second span, again I am applying summation of this vertical forces equal to 0, that is RB plus RC is equal to 30 into 4, that is 120. And considering moment at this point C is 0, RB into 4 will be positive moment since it is acting left side clockwise, and this 30 into 4 into 2 will be the moment here, and it will be negative since it is acting left side anti-clockwise. And this 44.12 is also anti-clockwise moment acting left side, so it will be negative, and by which is equal to 0, and by calculating this value we will get RB value as 71 kilonewtons and RC value as 120 minus 71, that is 49 kilonewtons. So now the next step is to find out the final support reactions, that is to add these values. Here we had only one RA value, that is 26.47 kilonewtons, and we had two RB values. By adding both these values 33.53 and 71, we will get it as 104.53 kilonewtons RB and RC as 49 kilonewtons. And now the final step is to draw the bending moment diagrams and shear force diagrams. So this is our actual beam, and these are the values calculated by us. Now we had already calculated and drawn this bending moment diagram. Here this is WL square by 8, that is 45, and this WL square by 8 gives us 60. And coming to the remaining part of the bending moment diagram, here MA is 22.94 value here, and coming to this point MB is minus 44.12. So I had joined both the points using a straight line, and from here to here it is 0, MC is 0, so I had joined this. This is our bending moment diagram. And coming to shear force diagram, here the RA value is 26.47, and since it is acting with UDL, it will be a varying line from here to somewhere here, that is the point here will be 26.47 minus this value, that is 10 into 660, gives me 33.53. And now till here it will be from here to here it will be 33.53, and again at this point B there is a force 104.53 acting here. So minus 33.53 plus 104.53 gives me this value, that is 71. Now again it is acting with UDL, so I need to subtract this value from here, and the shear force diagram will be a varying line. 71 minus this 30 into 4, that is 120, gives me minus 49. This is our shear force diagram. So in the upcoming class, I will give you another example of a continuous beam analysis using three moment equation of varying flexural rigidity. Thank you. Please like, share and subscribe.